Hello, everybody. My name is Paul Beckwith, and in my last video, my recent video, I talked about some of the consequences of an AMOC shutdown. I talked about what happened in the so-called 4.2K event 4,200 years ago, which is about 2,200 before Common Era, when many civilizations just vanished off the face of the earth. They either died off or moved, and lots of that turmoil was attributed to a long-term drought and heat lasting a century at least. So what I want to do in this video is show you some images and discuss this in a bit more detail. What happened in the 4.2K event, are we heading that way right now with the AMOC shutdown? And, I've been thinking about some of the things that, I'm from Canada, and Carney's our Prime Minister, and he's talking about these mega projects. And one of the things that struck me is they're talking about it greatly expanding the port of Churchill, Manitoba. So with more and more warming, the port would be open more than the 3 or 4 months a year that is currently open. And, if the Arctic got super warm, it could be open, half the year more. However, if the AMOC fails, it's going to be shut year round. It'll hardly be open at all. It'll be a colossal waste of money. So, all these things are in the system. Okay, so let's talk about the 4.2K climate event. It was a severe and prolonged aridification or drying event marked by widespread drought that occurred about 4,200 years ago, about 2,200 BC. It's regarded as one of the most significant climate disruptions of the Holocene epoch. Marks the beginning of the Megalaic age, and so in geological timescales, it marks the beginning of a new event. It was so disruptive. Likely lasted for a century or more, couple hundred years. It had major impacts across multiple regions worldwide. The 4.2K event is associated with a substantial weakening of the AMOC, the Atlantic Meridional Overturning Circulation, that disrupted ocean currents and atmospheric patterns, and it caused a southward shift of the Intertropical Convergence Zone, the ITCZ, which is a band of storms circumventing in the tropics, and it can shift latitude depending on what's happening, including what's happening in the North Atlantic. Like with the AMOC shutdown, it shifts southward. The AMOC shutdown, or substantially weaker, means there's increased variability in the El Nino Southern Oscillations, the ENSO. We're also seeing this happen today. So there was significant precipitation reductions and temperature anomalies in the affected areas. So the 4.2K event triggered severe droughts in regions including Mesopotamia, the Indus Valley in India, parts of East Asia, and also North Africa, contributed to the collapse or major decline of several ancient civilizations like the Akkadian Empire, the Old Kingdom of Egypt, the Liangzhu culture in Asia, and the urban Harappan civilization of the Indus Valley. These droughts caused migrations and huge socioeconomic upheavals. So what happened? Well, the impacts varied depending on where you were. There were regional effects. So in Mesopotamia, the increased dryness was linked to the cooler North Atlantic sea surface temperatures. The East Asian monsoon systems weakened, so the AMOC failure can affect the monsoons in Asia, affecting billions of people today. So there were sharp humidity gradients and drought in northern China. Southern Africa saw wetter conditions because the ITCs had shifted down to cover those regions. So northern Africa, huge drought. Southern Africa, too much rainfall, flooding. Mediterranean showed a complex pattern of cooling and drying interspersed with wetter phases. So more weather whiplashing or weather wilding. So it was globally significant. The 4.2K events, geographic extent, and climate effects were spatially heterogeneous. So it depended on where you are as to what the effect was. They were complex. Some areas had wetter conditions instead of drought. Excuse me. There was a lot of ocean atmosphere circulation changes, jet stream changes with the AMOC failure. There was also potentially solar activity variations at that time, but they're still researching it. So what regions were most affected by the 4.2K event? And I'll show you some peer-reviewed papers in a bit. But the most severely affected regions were the Eastern Mediterranean, Northern Africa, West and South Asia, parts of East Asia, and the Mediterranean basin. There was aridification. When I first read that, I was thinking acidification. No, it's aridification or drying or drought. And that coincided with the collapse or transformation of major ancient civilizations. And the most impacted regions, North Africa and Egypt, the Old Kingdom of Egypt had societal turmoil and collapse. There was diminished flooding of the Nile. There's annual floods of the Nile, which are important for crops. That didn't happen. Fewer of them. Multi-year droughts in Egypt. Hard times. Mesopotamian and the Levant, the Akkadian Emperor, that's northeastern Syria, a couple large urban centers, had catastrophic drought and substantial population decline. Many cities were abandoned and settlements shrank dramatically. And I'll talk more about that in one of the peer-reviewed papers. Persian Gulf and Arabia Peninsula, the al-Nar culture ended, transitioning to another culture, protracted drought and changing water. The Indus Valley civilization, South Asia, severe monsoon failures and drought corresponded to the end and dispersal of the urban Harappan civilization. Major cities were abandoned. There was long-term demographic shifts. China, East Asia. Northern China had major reduction in the summer monsoon, so stark humidity gradient. Cultures like the Liangzhu and Longshan declined, especially in regions like the Lower Yangtze and river basins. Eastern Mediterranean and the Levant declines. Population estimates for the southern Levant suggested declines of up to 80 to 90%. We're talking about massive societal disruption. Many urban sites showed evidence of abrupt contraction and abandonment. So, agriculture led to the growth of cities. You lose your agriculture, the cities contract or are abandoned. There are other effects in Central Asia and Iran, water shortages, the Korean Peninsula and Japan, and Southern Africa. So all of these, so there's a table here of all of the different societal responses in different regions around the world to the 4.2K event, which was due to the AMOC, a severe slowdown of the AMOC. So many civilizations saw severe drying and collapse. Other regions had increased precipitation. Now, what climate model experiments reproduce the 4.2K kiloyear precipitation changes? So there's lots of models to try to figure out what happened there and how it relates to today. So they often look at the sea surface temperature changes, the land surface conditions, the atmospheric circulation. The best paleoclimate modeling shows that it combines SST anomalies in the eastern tropical Pacific, warming, and equatorial Atlantic cooling, desertification in northern Africa and Arabia. It's basically, they look at these statistical studies, and basically it requires the AMOC to happen, like to severely slow down in order to get these simulations to agree with what happened, what we think happened back in that time period. Okay, so dynamical explanations in the models. The precipitation anomalies are linked in the models to a weakened AMOC, shifts in the ITCZ, the Intertropical Convergence Zone, and atmospheric blocking associated with an intensified Siberian high. This combination of altered the ENSO and the regional land surface feedbacks, and we can reproduce the 4.2K climate disruption with with those things happening. So what role does AMOC weakening play in the model experiments? Well, the AMOC weakening, I call it the mother of all tipping points. Okay, it's the thing that a severe slowdown leading to shutdown of the AMOC would cause massive climate disruption around the world, droughts in many places, water scarcity, also difficulty to grow food, so it could lead to global famine. We're talking about, this can happen within the next few decades if the AMOC significantly slows along its present trajectory. And it changes the shifts in storm tracks and the ITCZ. So there's reduced precipitation in tropical, subtropical regions. So regions like the Middle East, North Africa, South Asia face significant monsoon weakening and drought with an AMOC slowdown. So it has huge effect on the monsoons, which have huge effect on billions of people, literally billions of people. And there's lots of ocean atmosphere feedbacks, desertification in some places. Okay, experiments that trigger an AMOC shutdown, like freshwater hosing, injecting lots of fresh water at high latitudes. That's what the melting of the ice and snow up in the Arctic is doing, causing SST anomalies. They can reproduce the patterns of the 4.2 kiloyear precipitation anomalies more accurately. AMOC weakening is central to simulating the pan-Eurasian drying, aridification, and monsoon failure seen in the paleo records. Okay, so the AMOC is basically, it's a key driver. AMOC weakening is a key driver. It'll shift atmospheric circulation and, affect the hydroclimate, the water impacts of the 4.2K event. How sensitive are the model's societal impacts to AMOC strength change? Well, the magnitude of AMOC decline is a major source of uncertainty in predicting regional temperature and precipitation trend. So a stronger AMOC decline results in reduced warming in some places, right? Northern hemisphere, where the warm water is not going. Changes in precipitation patterns, southward shift of the ITCZ. And those things directly affect food security, water resources. It affected the viability of ancient and modern societies dependent on these systems will affect. Okay, even small declines in AMOC, short of total collapse, may still have substantial societal repercussions through the modulation or change of monsoon systems and shift in the climate zones. Okay, so all of those factors are there. So let's have a look at, if you Google 4.2K event and select images, you can get all kinds of images of the regions most affected. And there was actually a 3.2K event. I love this Nutter's World. It's by this guy called Nick Nutter. Probably a Brit. Anyway, he talks about the 3.2K before present event. So the 4.2K, 2,000 years before Common Era, it wreaked havoc for a couple hundred years, at least a century. But then it looks like there was a smaller version called the 3.2K event, which he talks about here, different mega droughts and effects and so on. He's showing the event here. This would be the 3.2K event in terms of some different parameters in different places. And then the 4.2K event is up here. It's more of these shifts, which he's focused on the 3.2. Thought I'd show that. In European Geosciences Union, EGU, they had a whole, in their journal, Climate of the Past, they had a special issue, and it was all about the 4.2 kiloyear before present climate event, how it caused abrupt aridification and cooling. I mean, it's the most recent event that is attributed to an AMOC, severe AMOC shutdown or failure. This conference was in January of 2018. 60 people attended. You can get, there's loads of papers. It's asking, is there evidence for it? Atmospheric blocking. We learned an awful lot from the papers that were prepared. And here's one. This is on China. So there's different papers on how the 4.2K affected paleo records in all of these different regions of the world. I mean, a whole, how it affected ENSO and coral reefs and, hydroclimate, the Levant. Okay, so it's loads of information, scientific papers on this event. I just wanted to just show you the Akkadian Empire, ancient kingdom, often thought to be the first known empire in human history. It's centered on the city of Akkad and its surrounding region in modern-day Iraq, okay, and how it affected, huge influence on, so this is the map of the Akkadian Empire here in the Middle East. It affected, there was influence on Mesopotamia, the Levant, modern-day Iran, and so on. Established by Sargon of Akkad. Remember the chess game Sargon? And you could play against Akkad, I think, in the chess game. From years ago. History of Iraq. Okay, so they've got, if you look at history, I'm not going to go through all of the details and stuff, but I'll just go down, scroll down, the archaeology, dating, timeline of various rulers. So these are dates BC, the history and development of the empire. You can see region, maps and regions. The fall of the empire, submission of collapse. There you go. The empire fell in the 22nd century BC within 180 years of its founding, ushering in a dark age. Everything started to unravel. They talk about natural causes, drought, seasonal weather patterns. There you go, 4.2 kiloyear event. Now, it says that this is still a controversial theory, but I think it's becoming more and more accepted, especially when you tie it into the collapse of other civilizations in other regions of the world around that 4,200 years ago. They talk about regional decline in Egypt here, increasing dryness, failing rainfall in the ancient Near East, global centennial scale drought, also sometimes called the 4.2 kiloyear event. There's some of the original papers on this event. And they talk about, the land basically went to crap. I was going to say went to shite, but, it went to crap. I mean, they built stuff and then they abandoned stuff. Different cities sank by 75%. Skeleton-thin sheep and cattle died of drought. Up to 28,000 people abandoned the site, seeking wetter areas. Telbrak shrank by 75%. I mean, cities just collapsed. Just a skeleton number of people left in them. The collapse of rain-fed agriculture. Water levels of the Tigris and Euphrates, 1.5 meters below the level of 26 BC, right? I mean, it's like the end of the world there. Salinization of the fields, right? It's just everything collapsed there. So a lot of detail on the Akkadian Empire. Another one that collapsed at that time was the Old Kingdom of Egypt. It spanned 2700 to 2200 BC. Well, in 2200 BC, basically everything fell apart. And this is a 4.2K event. This period just before the age of the pyramids, the age of the pyramid builders, they built so many of this stuff before then. Conditions were fine. They could grow food. They had enough water. And then came the 4.2K event, and it just shifted everything. Everything there went to crap. So they called it the Old Kingdom in different ages because and this is the region. Look at the Nile here, coming up here, and look at cities in Egypt. I mean, Egypt doesn't exist without the Nile. And Sharm el-Sheikh is up over. Where did it go? Up over on the sea here. the climate conference. History, rise of the kingdom, height of the kingdom, fall of the king, decline of the different dynasties. I mean, there was a lot of other things going on, right? But climate was like a nail in the coffin. You know, I mean, some of these kingdoms just grew too much. They didn't have, there wasn't enough water, resources, many different factors. It's complex, right? Human history is complex. But, you know, it looked like the last straw was the 4.2K event. And then we have the Liangzhu culture. Here we go in China, and we're talking about this region. Very advanced culture. And there's basically ruins. It's a UNESCO World Site. It flourished around 2500 BC. It disappeared from around 2300 BC. Almost no traces of the culture were found from the following years in the area. So this was a culture that was well developed, and then it just kind of vanished. Okay, so you know, why did it vanish? They talk about the idea that the monsoons were failing. They relate it to the Indus, Old Kingdom Egypt, the Akkadian Empire falls, global droughts occurring, you know, 4.2K event. That would be 4.3K maybe in this case. You know, things changed. Anyway, there was a lot of different regional stuff going on. So this was a very advanced civilization. And then in India, the Indus Valley civilizations here, okay, South Asia lasted from 3,300 before Common Era to 1,300. And in its mature form from 2,600 to 1,900. It had huge stresses on it at the 4.2K, from the 4.2K event again. And they talk about some of the sites here and the archaeology and what they find. And, you know, it's like the Indus Valley civilization. It was contemporary with other riverine civilizations of the ancient world. Ancient Egypt along the Nile. Mesopotamia in the land was watered by the Euphrates and the Tigris River. China, the drainage basin of the Yellow River and the Yangtze. By the time of its mature phase, it had spread over an area larger than the others. Okay, it was huge, and then everything went to crap in that. And again, they talk about the 4.2K event further down. What happened to the cities and so on, the different leaders and rulers, and the early period, 3,300 to 2,600. And then the mature period, 2,600 to 1,900, and then how parts of it just got hollowed out. But it seemed to be, you know, there were so many people there. There was some resilience. You know, I mean, it could take, it can depend, you know, some rivers dry out at different rates and things. So maybe this river lasted a bit longer, say, than, you know, some of the other collapses that I showed you. And then this is a good paper. This is a peer-reviewed paper that was published a few years ago. Collapse and continuity, a multi-proxy. So they used a lot of different data sources. They tried to reconstruct the settlement organization and the population trajectories in the northern Fertile Crescent. Okay, you've heard the term Fertile Crescent. I mean, sort of the cradle of civilization. And the 4.2K event nixed it, basically. So this is what the AMOC can do. Don't underestimate what the AMOC can do to human society, human civilizations on this planet. And, you know, everybody's just ignoring it right now. Anyway, so what happened to the Fertile Crescent during the 4.2 kiloyear rapid climate change event, abrupt climate event? So I'll just talk about this and show you some images. The rise and fall of ancient societies have been attributed to rapid climate change events. Well, have we learned anything from the history? One of the most discussed of these is the 4.2K event, period of increased aridity and cooling posited as the cause of societal chaos changes across the globe, including the collapse of the Akkadian Empire in Mesopotamia. Studies seeking to correlate social and climate changes around the 4.2K kiloyear event have tended to focus either on highly localized analysis of specific sites or surveys of different overviews. So here they take an empirical approach at a large spatial scale, and they look at trends in population and settlement across the entirety of the northern Fertile Crescent, which is northern Mesopotamia and the northern Levant, from 6,000 to 3,000 calendar years before present. And they look at distributions, they look at radiocarbon dating and data from 18 archaeological sites as proxies for population. And so they see long-term trends of increased population and urbanization supported by unsustainable overshoot, and then a drier zone, crop failure. They argue that the 4.2 kiloyear event occurred during a period of unprecedented urban and rural growth, but then it caused that to halt and to reverse. But the growth may have been unsustainable even without this abrupt climate forcing, they say. So the rise and especially fall of ancient societies have been attributed to rapid climate change events, right? And they go on and talk about the details, but they look, so these are the regions. This is the survey site. So they look at a vast region in the Middle East, and they look at all these different survey sites and population trends from proxies, etc. It's mostly, so these are some of the abbreviations. I think they use some they use the AVRP. These are that's the AMOC Valley Regional Project, 178 sites, 538 square kilometers. So they look at all of these different sites, and they look at the demographic trends, and they look at the 4.2K event and how it affected all of the various trends. Okay, so they have lots of these sort of maps here. They looked at rainfall amounts, different statistical trends, raw counts of number of people, and this is urban area 200 year. So urban area 4,000 BC, grow 3,800 BC, getting growth here, 3,600, 4,000, and so on. You can see growth and decline, and then massive growth here. Look at the population densities in these regions, massive growth. And then suddenly many regions here, you can see these regions, they just kind of taper off and vanish. Some of them are still there, right? Many of them depends on the property of rivers. So they do this detailed study, lots of data. I'm not going to, I've told you the result. They're saying that there was big disruption from the 4.2K event in those regions. And there was also other factors that could have caused great reductions of population. But this is a real cautionary tale from history that tells us what's going to happen to our world if the AMOC continues to strongly weaken and fail. Well, we're going to get societal disruption. We're going to get famine in many places of the world. We're going to get water scarcity. And this is all happening. The AMOC is a mother of all tipping points, I like to say. Anyway, thanks for listening. Please go to my website, paulbeckwith.net, and donate to PayPal to support my research and videos. Thanks again. Bye for now.